This is the first question of passage 4. It says, according to the data presented in the passage, 5-HTR4 is a blank. All right, so let's take a look at what 5-HTR4 is. And we see that we have some information about 5-HTR4 here, but it doesn't exactly say what it is. All we know is that it's a transmembrane receptor. And if you go through this passage, you'll notice that it doesn't actually explicitly state. So you have to do a little bit of inferring here as to what 5-HTR4 exactly is. And you'll notice in figure 2 that we see the relation between CAMP levels and 5-HTR4. So what that tells us is if we're measuring CAMP levels, depending on whether or not we have 5-HTR4 or not, what that tells us is that 5-HTR4 is probably going to be related directly to CAMP. So if we're looking at a CAMP, the immediate answer that should pop into your head is the G protein coupled receptor. So just know that CAMP and GPCRs are always tied together. And as for why the other answers are wrong, protein kinases, we don't see anything about 5-HTR4 phosphorylating anything with ATP, so that rules out a kinase. Same idea with tyrosine kinase receptor, we don't see any phosphorylation events with ATP, so it can't be B either. And finally, we don't see anything about 5-HTR4 acting as an ion channel, specifically a ligand-gated ion channel. So we don't see anything going through this transmembrane receptor, which would make it an ion channel, making C incorrect as well, making D the correct answer. Let's take a look at the next question. It says 5-HT is synthesized from a single amino acid by a short metabolic pathway consisting of a hydroxylation reaction followed by a decarboxylation reaction. The chemical structure of 5-HT is shown. So what is the amino acid that 5-HT is synthesized from? Well, notice then is that what this question is telling us is if we were to add a carboxyl group onto this structure, and then we were to take away a hydroxyl group, then we should get some kind of amino acid. As you guys look at this, or as I'm looking at this at least, I immediately see a structure that reminds me of the side chain of one other amino acid. And that's going to be this structure right here. This really looks like the side chain of tryptophan. And so let's take some measures to make sure that that's exactly what this is. So it says we see 5-HT is made from a decarboxylation reaction. So that means we should be able to add a carboxyl group here somewhere, and it would make it look a little bit more like an amino acid. And so what if we chose right here, right? Oh, let me just send this to the back. All right, so if we chose this group right here, well, immediately, this looks like a carboxylic acid. You have the alpha amine group, the alpha carboxylic group, or carboxyl group, and then you have the R group right here, right? This is our R group. And so this so far makes sense. And in this R group, it doesn't look exactly like the side chain of tryptophan. Remember, 5-HT, we get that by hydroxylating the side chain, or hydroxylating something. And so we can reasonably assume this is the hydroxyl group. This is the hydroxylation reaction that occurs. So if we were to take this away, well, if you look at the rest of the molecule, there we go. We have the exact structure of tryptophan. So we can presume that this is tryptophan. If you look at the structures of A, B, and C, there's really no way to add on a carboxyl group and take away a hydroxyl group from this entire structure and make it look like any of these. Specifically, this side chain really only points you to D instead of A, B, and C. So that makes D the correct answer for this question. All right, the next question says, in an experiment in which IBU alone was administered to normal mice in order to determine whether long-term treatment with the analgesic, don't know if I said that right, can cause behavioral problems or behavioral symptoms of depression, what would be the appropriate control group? So guys, remember, we're looking at some kind of treatment. We're going to add it to one group, okay? And we want to see if we get some kind of, this is group 1, and we want to see if we get some kind of difference. And here, that difference is we're looking for symptoms of depression. Now they're asking, okay, how can we have a control group to which to compare the results from the first group? Let's look at the answer choices here. It says normal mice treated with an SSRI, right? So SSRIs, we know that those are the antidepressants, as it says in the passage. They help alleviate symptoms of depression. So if we take a group, we give them SSRIs, Well, we're pretty certain they're not going to be depressed, right? Now, if we compare a group with IBU, so let's say this is G2, we give them SSRIs, okay? Let's say we give group 1 the IBU and it does cause symptoms of depression. Well, if we compare that to group 2 where we use SSRIs, well, we know for a fact that the symptoms of depression have to decrease because we know SSRIs are a known antidepressant. So let's say the depression level of these guys, these mice are like 20%, okay? This is obviously just a made up fact. Now, if we look at IBU from group 1, the IBU treated group 1, let's say the depression levels are 50%. Well, here's what we don't know. We don't know if this 50% is because IBU increased depression levels, because even though 50% is higher than 20%, you can also imagine that IBU doesn't cause symptoms of depression, and 50% depression is just a normal baseline for all mice, regardless of their treatment, or specifically untreated mice. So then if we use this as a control, we're almost likely going to always get numbers that are higher, depressive symptoms, higher than 20% in the IBU treated group, even if IBU doesn't cause symptoms of depression. And that's just because SSRIs are known to decrease the symptoms of depression in all mice. So that's why we don't want to use A. Now, we're looking at B and D. We immediately want to rule out depressed mice. Why? Because if we use depressed mice, that's going to be a very hard control for us to use to see if IBU causes depression or not, right? So let's say with these guys, group 2, they're just already depressed. They're always at 80% depression, okay? Well, if we treat with IBU in group 1, which are normal mice, let's say we have 50% depression again. Well, we don't know what the baseline was. We need to know where these mice started off. And if we're just comparing to an 80% depression rate in the mice that we already know are depressed, these numbers might always look lower, or they might look similar to this. We just can't tell if that's IBU causing depression or not. The most important fact that we have to keep in mind right now is that we want a clean slate. If we want to know that if IBU itself has an effect, then we want to also make sure that non-IBU, so in other words, something that isn't IBU, that shouldn't have any effect, is also used as a control in our experiment. That's why we want to look at C. We want to look at mice treated with a placebo. We want to compare mice that haven't been treated with anything that will change their depressive levels to see if IBU is increasing depression in the mice. So that's why the answer is C for this problem. Let's move on to the last question of this passage. It says, which comparison best determines whether IFN gamma is necessary for antidepressant-induced increases in the expression of P11? Expression levels of P11 in blank. All right, so what is this asking? We're trying to see if IFN gamma is necessary for this increase in P11 when we give patients antidepressants. All right, so what's the antidepressant we're looking at in this passage? We're probably going to be looking at SSRIs. And you can double check this fact by the fact that all of these A, B, C, and D, all of them look at SSRIs. All right, so let's look at the answer choices here. That says A, wild-type mice versus IFN gamma knockout mice, both treated with P11. Guys, if we're looking to see if IFN gamma is necessary for an increase of P11 in antidepressant-induced patients, we want to make sure that our experiment's going to have some antidepressants in the sample or in the experiment, right? So in A, we don't have antidepressants mentioned at all. What we're just basically doing here is we have wild-type mice, and then we also have mice that have this IFN gamma gene knocked out, okay, so KO'd. And we're just going to both add P11, give this guy P11 as well, and we're just going to see, okay, let's compare the levels of P11. This doesn't address the fact that, or this doesn't address the question of whether or not IFN gamma is necessary for antidepressant-induced increase of P11. We're just directly giving them P11, right? So because this doesn't contain any mention of antidepressants, A has to be the wrong answer. B says wild-type mice versus IFN gamma knockout mice, both treated with an SSRI. Well, this looks pretty promising, right? So we have wild-type mice, okay? And then we have the IFN gamma knockout mice. So we KO'd IFN gamma, all right? And then we're gonna give them both SSRIs. And then we're gonna look for the increase of P11, right? And we would expect that the mice with IFN gamma KO'd, if IFN gamma KO is necessary for the increase of P11 due to SSRIs, then in this case, in these mice, we would see a lower level of P11 compared to these mice right here. Okay, so what we're essentially doing here is, in this mice, we're taking away IF and gamma, giving them SSRIs, and then we're seeing, okay, now what? Do we see an increase in P11 that we would see in the wild type mice, right? And if we, depending on whether or not you see an increase or a decrease, or an increase or no increase in P11, then that will give you an insight into, okay, IF and gamma is needed for SSRI-induced P11 increase, or it is not needed for SSRI-induced P11 increase. So B so far checks out to be a pretty good answer. Let me get rid of all of this. All right, let's take a look at C. C says wild-type mice treated with IF and gamma versus wild-type mice treated with SSRIs. All right, so we have IF and gamma treated mice, and then we have SSRI treated mice. And we're going to look for expression levels of P11, right? Why doesn't this answer our question here? Again, we want to make sure that we're looking at SSRI's effect on P11 increase. So in this case, we have the right idea. We're giving wild-type mice SSRIs, and we want to see if this increases P11. And given our previous results, we know that antidepressants induce an increase of P11. So we're expecting P11s to increase here. Now, if we give these mice IF and gamma, we are already adding something that the mice already have, right? So regardless of if P11 increases, that could just be because IF and gamma itself, additional IF and gamma doesn't have any effect on inducing P11 expression after you give them SSRIs. But more importantly, you're not giving this mice any SSRIs to begin with, right? So then if we see an increase on P11, we don't know if this is due to the SSRI-induced increase of P11, or if it's because IF and gamma itself increases P11. We don't have the connection between SSRIs and IF and gamma here because we don't have any SSRIs in this group to begin with, making C the incorrect answer. Just again, to reiterate, if we're looking for the connection between SSRIs, IF and gamma, and P11, well, on the right-hand side, we see SSRIs, P11, we see this entire picture, but on the left-hand side, if we don't add any SSRIs, we're just looking at this level right here. So we're asking ourselves, does IF and gamma increase P11? Not does SSRIs increase P11 through IF and gamma. So because we're not adding SSRIs, because we don't have the full picture of this pathway here on the left side, C has to be incorrect. Finally, D says wild-type mice treated with IF and gamma versus wild-type mice treated with ibuprofen. Exact same idea as before. We have this group right here for D, and then we have wild-type mice treated with ibuprofen. Guys, ibuprofen is not an SSRI. We don't have any idea of what, or we do in the passage, but we don't have any connection between SSRIs and IF and gamma if we treat wild-type mice with ibuprofen. Matter of fact, ibuprofen is it inhibits antidepressant response. So we're actually doing the opposite. We're taking away, it's almost like we're taking away SSRIs. But regardless, again, because we're not actually assaying the actual effect of SSRIs on P11, with or without IF and gamma, D has to be incorrect as well because we don't get that full picture like I've just talked about.